Hi everyone, welcome back to our YouTube channel Becoming a ROS Developer. I am Desire, and today we've got Aaryan, who is just completed the course Python Basics for Robotics. So what we'll be seeing is a demonstration of his code base on a real robot as usual, and then we'll get into the details about his project. So I will now hand over the platform to him so that he can begin his presentation. Alright, whenever you're ready,
Hello.
Aaryan, go ahead.
Okay. Uh, First, I will start tell you keyboard.
Okay, just one sec. Okay, you can go ahead.
Okay.
All right, may you be explaining what you're trying to do as you go?
First, I have started tell you keyboard,
Mm-hmm.
which will be helpful for us when work, we can get some errors like our turtle boat is striking to the walls. So we can control manually by tell you keyboard
Okay,
for emergency control.
okay,
And, uh, and then I am starting my code, which is in Python. First, I will going to be start my class version of code.
mm-hmm.
So it is starting. So now code is started.
Okay.
I think it is getting some. Or so can I move a little bit manually? Then I start my code again.
It's fine, it's fine. Um, do whatever fault finding you need to do so that you get your robot to respond.
Started.
Okay, all right.
So it will detect the wall and it will maintain some distance from the wall. Then it will go straight. And when another wall is coming in the front,
Mm-hmm.
it will turn.
Okay.
So we can see that we are getting the roll pitch and yaw values,
Mm-hmm.
which are the Euler values, Euler angles.
Mm-hmm.
So and we are also getting the total distance traveled.
Mm-hmm.
and it will first stop when the obstacle means wall is detected. Then uh, it will find the way which is available to go ahead.
Mm-hmm.
I think again it is stuck due to some logical error.
All right, it's constantly saying detected an obstacle and then does not find a way of going around it. Okay. Did you do any implementation to handle that?
Last time I tried, it was working well.
Okay, all right, I see. But it did manage to follow the wall for most part. We can see at least half of it.
No, got it. Mm, I don't know why it is not working well as it was working in last time.
Okay, I can see that. Can you try have it start from a different corner and let's see?
Yes, okay. Now it is moving. Now it is working.
All right, let's wait for it to complete.
Okay.
All right, I think that's about where it started, right? Let's just pause.
Mm.
All right, so can you take us through what you did to make it behave in such manner? Can you go through your code base so we see what you did?
Okay. This is net code.
All
Uh,
right.
I have first initialized the XY and the role which you total listen all values to 0.
Mm-hmm.
Right. And this is the function for odometry
Mm-hmm.
position which I will getting.
All right.
And,
Was your terminal
and this is for velocity
all right? All right. Was your terminal displaying your odometry? I can. Let's just check.
code or
Um, I just analyze that one. All right. All right. All right. I see. So laser distance is okay. All right. Let's go back to the code base.
this is for the velocity control.
Mm-hmm.
And this laser callback for uh, getting a distance value from the lidar.
Mm-hmm. Mm-hmm.
Mhm.
Can you?
Then I have implemented implemented this for not getting infinite values or incorrect values.
Mm-hmm. All right. Can you take us through what the function above the laser scan callback? Yes.
This function.
Yes. Can you explain a little bit more how you're processing that data?
Uh, by this we are interacting with the uh, laser at the 36 degree, which mean front laser. So we can get the front distance,
Mm-hmm.
and we are calling it again and again for the different values of laser, like for the uh, rightmost,
Mm-hmm.
leftmost, and the range between front and right, front and left
Mm-hmm. Okay.
in the further code.
All right. All right. Let's go on.
Mm. This function I have made, which I said you earlier. Um, in um, this variable position, suppose we will enter the position which we want to get access of lidar laser, which mean as we did first 36 number, it was front laser. When we pass the array from the 36 to 180 or 36 to 540,
Mm-hmm.
which is range from front to left and front to right.
Okay. Okay.
Uh, this function I have made to move the robot
All right.
by giving the linear and angular velocity.
Mm-hmm.
Uh, this I have used in mm, all the code for like move forward logic, move backward logic. This is I have given default value of speed 0 0.1,
Mm-hmm.
uh, and I have passed this as linear velocity, and angular velocity is 0,
Mm-hmm. Okay.
so it can move forward. And for the backward logic, I have made speed as a negative, so it can go backward, and
Mm-hmm.
angular velocity is 0.
Okay.
And for left and right motion, I have made linear velocity 0 and the angular velocity as 0 0.1
All
here.
right. All right.
And for the stop logic, I have given 0 0 as linear and angular velocity.
Okay. How do you determine that it has reached the distance where it's supposed to stop? Is it somewhere else
Okay,
in your code? All right.
okay, I'm sure. Uh, this is the main code. Uh, it is in a while loop, so it will start again and again.
Mm-hmm. Okay.
So first, it will initialize nodes and this from here starting.
Mm-hmm.
Uh, when the object is at 0 0.6 meter, it will detect an obstacle and it will go in a condition. Then it will check uh, whether to turn left or whether to turn right. This is
Okay.
the condition. If the distance is detected less than 0 0.6, it will run a function turn.
Why did you choose
So
zero?
can I show you a
Uh, just hang on. Okay, so you say that when the distance is less than 0.6, do you mean the threshold, the distance in front of the robot?
threshold?
Okay, all right, I see, I see.
Can I show you this function,
Mm-hmm. Sure. Yes.
which will decide whether to turn left or right?
Yes.
Okay, this is the function. First, it will detect the left distance, then it will detect right, then it will compare which one is larger,
Okay.
so where to move, and little bit delay, 1.2 seconds.
Mm-hmm.
And again, I have used this to not get infinite values.
All right, for your laser scan data. Okay.
Okay, this was all about my code
All right.
and presentation.
Right. Okay. Your main control loop, where your robot makes decisions to turn left or turn right, is that the function you've just shown me, or you have another control loop that?
This was the function.
Okay. All right. All right. All right. So it's I do understand what you did. It's just that I wish you would explain more in detail some of the things you, how you got to those things, right? But it's fine. We do understand. We know it works, and we understand the control loop you're using. Um, it's just that it feels like some bits and pieces that you're skipping are quite relevant to this, but it's all right. So, just a couple of questions I've got for you, particularly pertaining to the language that you used, right? So, in Python, we know that we have got tuples and lists, right? Can you explain some of the differences between those two?
And in list, we can change the values further in a runtime,
Mm-hmm.
and in tuples, we can
And then say that again.
um, in a list we can change the value, and in tuple we cannot change the values at runtime.
Okay, so are you saying in a tuple you can also change values?
Means I, I can't hear.
Are you saying you can also change values in a tuple?
No, we cannot change the values in tuple. We can change values in list
Okay, all
at
right,
runtime.
all right, all right, all right. I understand that. I understand that. Then the other thing I wanted to ask you is about scope, right? So in Python, how do you specify differences in scope, right? So let's say you define a function. How do you ensure that the code you write in that function will be in that function scope, right? What is the, it's one of the main characteristics of Python, right? What is that?
I cannot understand the question.
All right, so you do know that when you define a function, for example, right, they,
Hmm?
you have to show which statements will be executed when that function is called, right? So how do
Hmm.
you specify the the scope of that function, basically?
function.
Did you understand my question? Did you understand my question, Ayan?
Not clearly.
Not clearly. Okay, all right. So, I think I'll just give you a hunch. What I was looking for specifically, or to just lead you in the right direction, is when you define a function, right? In Python, most of the time, the only way you do specify which statements will be executed after your function. For example, just after the colon is by using indentation, right? That's why it's sensitive to different types of indentations that you use, right? Or if you don't indent, then you get an error, right? So I was
Mm,
just looking something along the lines of the use of indentation in general, right? Um, but all right, that's fine. Let me see if I have any more questions for you. Can you explain a little bit more how you did your odometry? How did you track the distance the robot moved, right? Just off the top of your head. What's the logic?
mm. Now first, it will get the X and Y values
Mm-hmm.
from the leader or the robot.
Mm-hmm.
Mm. Uh, then it will check um, previous X, and it will find the change in X position,
Mm-hmm.
which is delta X or dx.
Mm-hmm.
X minus previous X, which was the previous value. It will substitute and find the difference, and then just simple mathematical uh, square root of x square plus y square, which will give the distance traveled,
Mm-hmm.
and it will update in total distance. So total distance will get updated.
All right. All right. On the basis of that function that you're using. Okay, I see. All right. Can you explain just a little bit more? Um, just hang on one sec. So you do make use of Euclidean distance. I see. All right. All right. I understand.
Mm.
All right, Ayan. Thank you for your presentation. So what I would say is you just hang on and we will conclude our conversation on Zoom. All right. All right, everyone. So this was Aryan's presentation, and I do encourage any one of you who would like to take a test on some of the courses that we offer certification on to do so, and then you can come and make your presentation. And until next time, we encourage you to keep pushing your ROS learning. Bye bye.
Thank you, sir.